RR rotation. What is RR rotation? That is insert. Is it visible to you?
Yes, sir, it's visible.
Yes,
Yes,
sir.
sir.
Yes.
Yes, sir.
RR rotation means inserted node is in the right subtree of the right subtree of node A. Okay. So A is the root node. Here we assume A is our root node. Now, if A is your root node, okay, and uh, let this is your left portion, left subtree of A, that is AL. Okay. Let this is the last node leave. Say for example, and let this is any intermediate node B. Okay, and this is BL and left subtree of B. This is your BL and this is your BR, right subtree, BR. Okay. Now inserted node is in the right subtree of right subtree. It is RR. Inserted node is in the right subtree of right subtree. So insert X here. Let this is your X. This is your X. Okay. Now before insertion, what will be the balance factor of AL? This is 0. Okay. Balance factor of BL, obviously 0. Balance factor of BR, this is again 0 before insertion. And balance factor of B is 0. So balance factor of A, what will be the balance factor?
Minus 1.
Minus 1. Why plus 1? This will be minus 1 because its right branch, because the height of the right subtree is greater than the left subtree. Say for example, let this is A, this is your A, and this is B, B, uh, let C, and D. Let this is your E. So this is the tree structure. So what will be the balance factor of A? For C and D, this will be 0, 0. For E, it will be 0. For B, it is 0. And for A, as the height of the right subtree is greater than height of the left subtree, so this will be minus 1. Is it clear to you? Now X
Yes,
is inserted. X is inserted. Okay. So after insertion
yes,
of
sir.
X, so X is inserted in the right X is inserted in the right subtree of A. So right subtree of A. Let this is your X. Okay. So X is inserted in the right subtree. This is your right subtree of right subtree. This is your outer right subtree of root node A. So what will be the balance factor of X? Balance factor of X is 0. Balance factor of C is 0. Balance factor of E is 0. What is balance factor of D?
D is minus 1, B is
Minus
minus
D,
1.
D is minus 1. So balance factor of D is minus 1. Similarly, balance factor of B is
minus 1,
Minus 1.
minus 1. And balance factor of A
minus 2.
minus 2. So balance factor belongs to the 0 plus 1 minus 1. It is minus 2. So it is violated. Now you have to uh, modify the rotation. You have to modify the tree. So here the RR rotation is required. So this is RR. This rotation anti-clockwise RR, clockwise this is your LL. Okay, this is your LL rotation and this is your RR rotation. Okay, so RR rotation. So after RR rotation, B will be your root node. So left portion of B, just rotate B in anti-clockwise direction. Okay. rotate your B in the anti-clockwise direction. So left side of B, this is
A.
your A. Okay, left side of A, this is your
E.
AL. Okay, so I am using this particular structure. So AL, this will be your AL left branch. This is actually E. Okay, so AL, and this will be your
BR.
BR plus X. Okay, so this will be your BR plus X, BR plus X, BR plus X. So,
BL will be with A.
yes. So this is BR plus X, and BL will be right portion of A. So this is the height balanced. Okay, so this is the height balanced tree. Let us have an example. Let the tree is 34. This is the binary search tree. 34. Suppose 34. Just 1 second. RR rotation. Let 34, 26, 44, 56, 40 is given. So this is given. You have to construct the tree. So how to construct the tree? 34 is the root. So 34 is the root. Next, 26. So 26 is less than 34. So 26. And next, 44. So you have to check every time the balance. Is it balanced? After insertion 34, 26 and 44, is it balanced or not?
Yes, sir. Yes, sir.
Yes, sir. Balance.
So it is balanced. Next one is 56. So 56 means
Right child of 44.
right child of 44, because 56 is, you have to check whether 56 is greater than 34 or not. Yes. 44 or not. Yes. So 56 is inserted at the right child of 44. Okay, 56 is inserted. Next, 40. So 40 is greater than 34 but less than 44. So this will be 40. Is it balanced or not? Full,
Yes.
full structure.
Balanced.
So full balanced, because the 34, for 34, what is the balance factor of 34?
-1.
-1 is the
Minus
balance factor.
Minus.
-1 is the balance factor of 34. Okay, this is for 26, this is 0. For 40, this is 44, this is 0. 40, this is 0. And 56, this is 0. Okay, now you are asked to insert 65. So what is the appropriate position of 65? You are asked to insert the node
Right child of
65.
56.
So 65 is greater than 34. It is actually your AVL tree, height balanced AVL tree is actually the binary search tree. It follows the binary search tree property. So every node at the right child are greater than your root. So 65 is greater than 34, then 44, 56. So 56, so appropriate position is 65. Now, is it balanced or not?
No, sir.
So balance factor of 65 is 0. Okay. So balance factor of 56?
-1.
Minus
Minus
1 is the -1. So balance factor of 44, this will be again -1. And balance factor of 34, this is
Minus
-2. Okay. So your 65 is inserted at the right subtree, of right subtree. Sorry. This should be right subtree of right subtree of 34. Okay, so What is the appropriate position? So 44, this is your B. So 44, there is a RR rotation. So 44 is the root. Okay, 44 is the root, and 44 is the root, and 34 is in the left of 34 is in the left of 44, and this is your 56. Okay, 56. Next, this is 26. Okay, is it clear to you? 56. So
Yes.
56, and here 56, 65,
65.
65, and 34. So for 34, this will be your
40.
40.
so it is completely height balanced. That is, balance factor are either 0, 1, or -1, and this follows the BST property. So this is the RR rotation. Is it clear? RR rotation.
Yes, sir.
Yes.
Yes, sir.
So RR
Yes,
rotation. Next, double rotations. We have to discuss the double rotation. LR rotation. So LL and RR, these two rotations are called the single rotation, okay, and LR and RL are called the double rotation. So LR rotation, this is your double rotation, okay. So LR, LR means you have to scan from right to left. So double rotation, and again you can thought this as the RR followed by RR followed by LL. LR rotation means your LR rotation. So LR rotation means you have to scan from right to left for your nomenclature. So first R comes. So RR is followed by LL rotation. Okay. That's why this is called the double rotation. First RR rotation, it is followed by LL rotation. So for RL rotation, LL is followed by RR rotation. Okay. Now let this is your A, and this is B. Let this is your BL, and this is another one, C, node number C. Okay, let this is CL, and this is CR. This is CR, and this is CL. This is CL, and let this is your AR. First, can you check the balance factor of every node using an arbitrary node, using arbitrary nodes? So let A, this is B,
Sorry. A will have -2.
minus,
2.
let this is C, last node. Sorry, this is let
Sir, if not -2, +2.
this is D. Okay, and let this is your C, and let this is E, F, E, and this is F, E, F, and let this is P. Okay. So this is 0, 0, 0, 0. Okay, so this will be minus 1.
Minus 1.
I had a minus one. Minus one.
So this is minus 1, and this will be
0.
0,
Plus
0, so plus 2.
Plus
So this is plus 2. Okay, this is plus 2. So this is not balanced. Okay. Now, inserted node is in the right subtree of left subtree of node A. Right subtree of left subtree. So if this is x, then this is the right subtree, okay, of left subtree. Right subtree of left subtree of node A. So x is inserted in the right subtree of left subtree of node A.
Sir, it can
Yes.
be inserted in CR2.
CR also. Yes, it can be inserted in CR also.
Okay.
That is right subtree of left subtree of node A. Okay. So if it is inserted in the CL, then first of all, your rotation should be LR. It is LR. Is it LR? No. It is inserted in the right LR. First R is scanned, then L. LR means first you should read R, then L. So it is inserted in the right subtree of left subtree. Okay. So what is the remedy? Remedy is RR followed by LL. Right subtree of left subtree of A. So this is the right subtree of left subtree of A. Okay. The insertion is clear to you? Where it is inserted?
yes.
Yes, sir.
Okay. Then RR is followed by LL. So first of all, this should be one RR rotation, and then again there will be a LL rotation. So C will be your root. In this case, C will be your root. So C will be your root. Okay, after two successive rotations, C will be your root. Here, after one single rotation, here the rotation in case of LL, it is clockwise. In case of LL, it is clockwise. In case of RR, this is anti-clockwise. So here we take an anti-clockwise move. That's why B is in the root. Here B is in the root. Okay. So after two successive rotations, C is now your root. Okay. So if C is the root, then A belongs to the right of C, and B belongs to the left of C. Okay. And from B, okay, and from B, this is your BL. This is your BL, left subtree of B, BL, and
CL.
CL plus X. Actually, this will be
plus
CL plus X. This will be your CL plus X. Okay. So this is your CL plus X. Okay. CL plus X. What about the A? So from A, right side of A, this will be your AR. This will be your last node AR,
Left side will be CR.
CR. So left side will be CR. Okay, so this is the notation. This is a little bit complicated rotation. So this will be your CR rotation. Actually, double rotations, LR and RL, these two rotations are little bit complicated compared to single rotation, LL and RR. Okay, here in case of double rotation, you have to rotate two times. First one for case of LR, RR followed by LL. In case of RL, LL followed by RR. So here, Shourashish, if you add x in the CR, if you add x in the CR, then then
A
your
will be CR plus X.
so x will be AL will be actually your this is your AL. This entire will be your AL. So AL will be CR plus x. Okay, is it clear?
Yes.
Yes, sir.
Let you are asked to insert 44, 30, 76, 16, 39. Okay. So what will be the appropriate tree structure? Anyone?
44 will be the root.
So 44 is our root. 44 is our root. Okay.
30 will be left child.
44 is the root, 30 will be the left. So 30 is the left child. Okay. 30 is the left child. And then
Child 70.
76.
76 is the right. 76 is the right.
Then left child of 30 is 16 and
16.
right child is 39.
16 and 30. Now check the balance.
Balance.
Yes, it's a hard balance.
So 44, what is the balance factor of 44?
Plus 1.
1.
Plus 1 is the balance factor of 44. Okay. And balance factor of 30 is 0, 76 is 0, 16 is 0, and 39 again this is 0. Okay. Now insert 37. Insert 37. So 37 is inserted. So 37 is inserted in which
Left
position?
child of 39. Left
So
child of
left child of 39. Okay. 37 is inserted. So 37 is inserted in the right child of the right subtree of the left subtree of 44. Okay. So this is the LR rotation. There should be a LR rotation required. Okay. So 39. So 39 should be rotated. This is the first rotation, RR rotation, then followed by LL. This is the second rotation. So 39 is the root. Okay. So 39 is the root. And after 39,
44, 76 will be right.
40,
44
44
is right side.
right, 44 is in the right, then 76 is in the right of 44. So from 30, so from 39, your left position is 30.
30.
Your left position 30. So left of left is
Left side will
16. Left
16.
of
right side will
right
be
side, right side will be 30. Is it clear?
Yes, sir.
yes.
So this is the LR rotation.
Sir,
LR rotation. Okay. So for RL rotation, what is the rotation for RL? Suppose RL, let this is your A. Okay. RL means at which position? Left subtree,
Left subtree of right subtree.
left subtree of right subtree. Let this is your B. This is your B. Let this is your C. Okay. C, and from C you are getting CL and CR. This is CL and this is your CR. So this is your CL. This is your CR. Okay. and let this is your BR, right child of B. This is your BR, and let this is your AL. Okay. Now this is your RL, RL rotation. So inserted node is in the left subtree of right subtree. So you can add either in CL or in CR. Say for example, we are adding in CR. Okay, Chodashish, we are adding in CR X. So
Okay,
this
sir.
is inserted in the left subtree of right subtree of A. Okay, so it means you have to scan from right to left. So first LL rotation followed by RR rotation. Okay, so LL rotation is followed by RR rotation. So LL rotation. So for LL rotation, C will be rotate in the clockwise. Then RR rotation, C will be rotate in the anti-clockwise. Okay, so C will be your head. So C will be your head. So at the left position, A will be there. So at the right position, B will be there. Okay. Then at the right of A, sorry, left of A. So for left of
AL.
A, AL. Right of A,
B. CL.
okay. Right of B is right of B is
BR.
BR is the right of B. Okay. Now left of B and right of A. So
Left, right of A will be CL,
this
and
will be your CL, and this
left
will be
of
your
B will be CR.
CR plus X. CR plus X.
CR plus X. Okay. Now you can check the balance. It is completely balanced. Okay. So this is the RL rotation. So let us have an example. This is a complex example from GATE 64 1. Okay. Then let this is 44 26. You can check this as 14. Okay. 14 26 13 110 98. Okay, 64, 1, 14, 26, 13, 110, 98, 85. So what should I do? So first inserted value is, first inserted value
64.
64. So 64 is inserted. Then
1 will be left child.
1 will be left child. So you have to check the balance. Every time you have to check the balance. So 1.
Yeah. Then
Next.
right child of 1 will be 14.
So right child of 1 will be, so omit this one. So this is 14. Now is it balanced or not?
No, sir, not balanced.
So after insertion 64, 1 and 14, every time when you are inserting 64, You have to check the balance. Yes, it is balanced because 0. Then you have to insert 1, okay, at the using the BST property, okay. So balance of 1 is 0 and balance of 64 will be plus 1. Now insert 14. So 14 means balance of 14 is 0, balance of 1 is minus 1,
Minus 1.
balance of 64 is plus 2. Okay?
Plus 2.
So plus 2, so it is not balanced. So this will be plus 2, this will be minus 1, and this will be 0. This is not balanced. So what should I do? Which rotation? You have to identify which rotation. This is a complex problem.
RL.
RR.
Is it RR, RL, LR, RR,
RL, RL.
Which one? RL.
Sir, LL.
Yes, sir.
Clockwise ঘুরবে মনে হয়, তাই না?
স্যার 14 রুট হবে 1 হবে লেফট আর 64 হবে রাইট
সবাই দেখো কি সব বলছে, দেখেছো? এইটাই হচ্ছে প্রবলেম। এই কোশ্চেন গুলো নরমাল ম্যাকআউটে এলেও প্রবলেম হয়ে যাবে।
স্যার পুরো ট্রিটা
আগে তোমাকে আগে না 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 আগে তোমাকে ভাবতে হবে হুইচ রোটেশন ইজ অ্যাপ্রোপ্রিয়েট রোটেশন। First of all, the procedure is insert every node one by one and using the BST property. Okay, insert every node using the BST property and every time you have to check the balance. এমনি এই কোশ্চেনটা দেয়নি। কি হবে এখনো বলতেই পারছে না যে কোন
এলআর 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 এলআর
14টা রুট হবে 1টা লেফট চাইল্ড হবে 64
ওয়াই এলআর কে বললো? এলআরটা কে বললো? ওয়াই এলআর
স্যার আমি আর সোহাম দে সরকার এটা
ওয়াই এলআর
So as because the 14 is inserted in left
14 is inserted in the
left in the right of left of 64.
right of left of 64. Yes, because 14 is inserted in the right subtree of left subtree. LR means you have to read from right to left. LR means insert the node in the right subtree of left subtree. This is the rule. LR means inserted node is in the right subtree of left subtree of node A. So here 14 is inserted in the right subtree of left subtree of 64. Is it clear to you? It is very complicated rotation. So LR rotation. So LR rotation means RR followed by LL. So first rotation is RR, then second rotation is LL. So which one is the root? First RR rotation, then LL rotation. So which one is the root?
14.
14 is the root.
14 is the root
14 is the root, and this is 64, and this is 64, and this is
1.
1. Is it clear, everyone?
Yes.
So now you have to check the balance. 0, 0,
Yes, sir.
and 0. 0, 0, 0. Next which value? 26. Ankita 113. Ankita 6 কোথায় হবে বলো তো? 26 which position?
So left of 26.
26 means which position? It is very complicated rotations.
So left of 64.
Yes, left of 64. So this is your 26. Now check again the balance. Is it violated or not? Quick.
no
Is it
sir not
violated or
violated.
not?
No, sir.
So 64. So 64 is plus 1. So 26 is 0. 1 is 0 and 14. So for 14, this will be minus 1. Okay, so this is not violated. Next inserted value is 13. So 13, which position 13? 13 means which position?
Right of 1.
Right of 1. Right of 1. So 13 will be. Now again check. Again check. So 13 is 0. 1 for 1. For 1, this will be minus 1. Okay. So for then 14. So 14 will be
0.
14 will be 0. Okay, very good. 14 will be 0. Okay. Next one. Next which one? Next one is 110. So 110. So 110 means which position? 110?
Right side of
Right side
64.
of 64.
Right side of 64. So 110 is the position. Now check. Again check the balance. So 110 is 0. 26 is 0. Okay. 13 is 0. This will be 64 will be 64 will be
0.
0. 64 will be 0 and 14 is 0. Okay. Is it clear? 14 is 0.
Yes, sir.
This picture should is becoming clumsy now. 98. So 98. What is the proper position of 98 now?
Left of 100.
Child of
Right of 110.
So 98. Now again check the balance. Check the balance. Is it balanced or not?
Yes,
So-
sir, balanced.
Balanced. It is balanced. Okay. Okay, it is balanced. Next one.
85, that will be left child of 98, and it will be unbalanced now.
85. So 85. Now 85 is the left child of 98. So 85 for 85 balance is 0. For 98 the balance is plus 1. For 110 the balance is
Plus
for
2.
110 the balance is
Plus
plus 2. Plus 2. Again for 64 the balance is for 64 the balance is
Minus 2.
Minus 2.
minus 2. Very good. Minus 2. And for 14 the balance is
Minus
Minus 2.
3.
Minus
Mm.
minus 2.
minus 2. Okay.
Minus
So at 3 different positions the balance is violated. Okay. Now the rule is that, what is the rule? You have to first check, starting from the leaf, you have to first check the node that is very close to the leaf, that is becoming that violate the balance factor. So the nearest root, that is where the balance factor is violated, is 110. So you have to modify the 110. First, you have to modify the 110. Okay. Then you have to check whether your new tree is balanced or not. Okay. So 110 should be modified. But which rotation is appropriate? Can you guess?
RR rotation.
LL.
কি আবার RR বলছে?
Sir, LL.
LL. Why LL? Because 85 is inserted at the left subtree
Left
of
of
left
98.
subtree of 110. Left subtree of 110. 85 is inserted in this position. So,
98 will be the root.
so LL rotation. LL rotation means this particular rotation. Okay.
Files.
Clockwise. So 98 is the root. Okay. 98 is the root. Okay. And
Left child is 85.
85. 110.
85 is the left child and 110 is the right child. Is it clear to you?
Yes,
Yes, sir.
Okay.
Yes, sir.
Then 64. There will be 64. Okay. This will be 64. And from 64, this will be the tree. Just I'm writing the normal tree. 26. Okay. So from 64, we are getting the root 14.
14.
Okay. So from 14, we are getting 1. the root 1. Okay, so from 1 we are getting 13. Okay, now check whether it is balanced or not. So 110 is 0, 85 is 0, 95, 98 is 0, 26 is 0. So 64, for 64
Minus
this will
one.
be
Minus 1.
Minus
minus,
one.
minus 1. 13 is 0, 1 is minus 1.
Minus
So 14, so for 14 is
-1.
minus 1.
minus one.
So your tree is now balanced. Is it clear to you?
Yes, sir.
This is a complex problem. Okay, so this is the height balanced binary search tree, ABL tree. The complexity of binary search height balanced binary search tree is order of log n, LGN. Okay, now what will be the output of this question? Is it visible? Question number 3.
Yes, sir. It's visible.
So it is নেক্সট ক্লাসটা কটা থেকে পুরো একদম রাইট টাইমে শুরু হয়?
না স্যার ম্যাম একটু লেট করেন।
আচ্ছা ঠিক আছে, তোমরা বলো তারপর জয়েন করে কি এরকম কিছু?
না ম্যাম আসেন, ম্যামের কোনো ঠিক নেই, 5 মিনিট 10 মিনিট পরে আসেন।
আচ্ছা ঠিক আছে, ওকে। The following C function take a simply linked list, single linked list as input argument. Okay, it modifies the list. It modifies the list by moving the last element to the front of the list and returns the modified list. Okay, some part of the list is given, you have to fill in the blank. Okay, so first one, this is your node structure using type def. This is your node structure, and if head is equal to null, so let this is the node structure. Using single linked list. Let this is the last node. Okay, so this is your starting node or start node or head node. Okay, now if head is equal to null, if head is equal to null, so head is equal to null,
Means list is empty.
list is empty. So if head is equal to null, this can be also written in this form. If head means your head is
Yeah, head has a value.
head has a value, so head is not null. So if not head, this means
Head is null.
yes, so head is null. If your head is null, this is equivalent to this notation. Is it clear to you everyone? If head is null, okay, or your head its next position, your next position is null. It means actually, so first part means your list is completely empty. Second part means
Have only one element.
only one element will be there, okay, and its next part is null. So it should be written in this form. If it should be Shourashish, it should be written in this form. Second part is written in this form. If head next, not head next, this is equivalent to head next is equal to null. Is it clear? Please clarify. These notations can be written in this form also. So this particular line can be written in this form if your head is null, or if your head is null, or your head or your head next is equal to null. You don't need to put any bracket because your arrow operator has highest precedence than not operation. Okay, so this will be executed. Okay, and again your not operation is highest precedence, greater precedence than your or operator. So these two functions will be executed, these two value will be executed, condition will be executed separately, and this is joined by or operation. Okay, so if your head is null, that is this is completely empty, and there will be only one single only one single element. Okay, so in your gate maybe 2020, this condition may be changed in this form also. Okay, so return your head. Now q is initialized to null. Okay, q is a pointer, q pointer is initialized to null, and p is head. Okay, now while your p arrow next not is equal to null, you have to copy the p in the pre pointer. Here actually q is used as a pre pointer. Okay, pre pointer of p. So p is copied in q and forward the p. So this will be your initially this will be your p. Okay, and then q is your first one. Next p is pointing at this position, so p will be now at this position. Again forward your p at this position, and then q will be at this position. Last p will be at this position and q will be at this position. Okay, is it clear? After the completion of the while loop, your final p will be at this position and your final q will be at this position. Is it clear to you after?
Yes, sir.
Yes.
Okay, then you have to write something in the blank. So this is the blank, you have to write something, and finally return head. Head is the argument. Okay, now it is given that the last element should be the front element. So last element should be the front element. What should I do?
Q next equals to null, P of next equals to head, head equals to P.
Very simple. So this will be your head node. This will be your head node. So first of all, you have to cross this portion. Okay, you have to cross this portion, and this will be your null. So q arrow next. So q arrow next is equal to your null. Q arrow next is equal to null. First condition. Then your p arrow next. So this is your head. This particular one is your head. So p this next. This next is equal to your head, and finally this is your head. So head is equal to, so h is equal to your p. So this is the condition. Okay, is it clear to you?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.